Hello, in this lecture we will find the value of 2 times AP. Okay, or we will find the size of 2 times AP. As you can see in the picture, we have a triangle ABC with size AB that equals to 90 units, size AC of triangle ABC equals to 70 units, and the side CB of the triangle equals to 50 units. We also have a circle, and the center of the circle is point P, and point P is situated inside AB of the triangle. And also we have 2 tangents to the circle. The first tangent is side AC of the triangle, or side AC of the triangle is tangent to the circle at point that we will call that point O. Okay, side AC of the triangle is tangent to the circle at point O, or the touching point between side AC of the triangle and the circle is point O. And also side CB of the triangle is tangent to the circle at point, we'll call that point E. Again, side CB of the triangle is tangent to the circle at point E, or the touching point between side CB of the triangle and the circle is point E. Okay, in the next step we'll connect points O and P together by a straight line. Actually, the point PO is the radius of the circle, because it starts from the point P, that is the center of the circle, and ends at point O, that is a point on the circle. So it is defined as the radius of the circle. We will call it R, abbreviation for radius. And we will connect points P and E together by a straight line. And also PE is the radius of the circle. For the same reason, we will call it R. Because it exits from point P, that is the center of the circle, and ends at point E, that is a point on the circle. So it is defined as the radius of this circle. And so we have 2 radiuses of this circle, OP and PE. And we actually have a rule that states that in any circle a radius and a tangent to that radius are perpendicular to each other. So the radius PO is perpendicular to AC, that is the tangent to the radius. Again, I will write it down. I will call it rule number 1. In any circle, a radius and the tangent to that radius are perpendicular to each other. So this is rule number 1. I will read it again. In any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, so actually the radius PO and the tangent to that radius AC are perpendicular to each other. So angle, that is to say angle POA equals to 90 degrees, and actually triangle AOP is a right triangle, and also angle POC also equals to 90 degrees. And in the same way, we can say that because of the fact that PE is the radius to this circle and the tangent to this radius is CB, according to our rule, they are perpendicular to each other. So angle PEC equals to 90 degrees, and also angle PEB also equals to 90 degrees. So triangle PEB is a right triangle. Okay, so in any circle, a radius, let's say that this is a radius, we call it R, and the tangent to that radius, this will be the tangent to that radius, let's call it T. So the radius and the tangent to that radius are perpendicular to each other. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay? Again, in any circle, the radius and the tangent to that radius are perpendicular to each other. That is to say, radius PO is perpendicular to AC, so angle POA equals to 90 degrees and also angle POC equals to 90 degrees. In the same way, we can say that because of the fact that PE, the radius of this circle, we have the PE, the radius of the circle, and the tangent CB, the tangent to this radius, according to our rule, they are perpendicular to each other, so PE is perpendicular to CB. That is to say, angle PEC equals to 90 degrees and also angle PEB equals to 90 degrees. And actually, as I've already told you, PEB, the triangle PEB is a right triangle, and also triangle POA is a right triangle. Okay? So in the next step, we will draw a perpendicular from point C to side AB of the triangle. And we will call to the touching point between the perpendicular to side AB of the triangle point M, capital M. So CM is perpendicular to side AB of the triangle. For that reason, angle CMB equals to 90 degrees, and also angle CMA also equals to 90 degrees. So actually we created another two right triangles, because triangle CMB is a right triangle because angle CMB is equals to 90 degrees, and for that reason triangle CMB is a right triangle, and also triangle CMA is also a right triangle because angle CMA equals to 90 degrees. Okay, so in total we actually have here four right triangles. The first right triangle is triangle AOP, because this angle is 90 degrees. The second right triangle is triangle ACM, because this angle is 90 degrees. The third triangle is triangle CMB, the right triangle CMB, because of the fact that angle CMB is 90 degrees. And the fourth right triangle is triangle BPE, is also a right triangle because angle PEP is 90 degrees. Okay, so we have here in total four right triangles, and in the next step we define angle AOP, or angle we will define angle CAB as angle alpha. So angle CAB is angle alpha, we can call it also angle OAB or angle OAP is defined as angle alpha, and we also will define angle CBA as angle beta. Again, angle CBA or CBP is angle beta, and we will also define AP as X. Okay, so AP equals to X, and PB will be equal to AB, that is 90 units, minus AP, that is X. So PB equals to 90 minus 6. Again, PB equals to AB minus AP, that is to say, to 90 units minus X. Okay, AB equals to 90 minus X, and we will focus on two right triangles. The right triangle AOP and the right triangle ACM. Okay, so again we will focus on the right triangle AOP and the right triangle ACM. So sinus alpha, that is defined as the ratio between the angle that is in a right triangle, it is defined as the ratio between the side that is in front of angle alpha divided by the hypotenuse of the triangle. So if we will focus on triangle AOP in the right triangle AOP, then sinus alpha will be equal to the side in triangle AOP that is in front of angle alpha, that is to say side OP of the right triangle, OP, divided by the hypotenuse of the right triangle, and the hypotenuse of triangle AOP is actually AP. Because in triangle AOP, side AO is perpendicular to side OP. So actually AO and OP are the perpendiculars of the right triangle, and AP is the hypotenuse of the right triangle AOP. Okay, so sinus alpha in the right triangle AOP equals to the angle, the ratio between the angle that is in front of angle alpha, the side that is in front of angle alpha, that is to say OP, divided by the hypotenuse of the triangle AOP, that is AP. So it is OP over AP. Okay, so now we will focus on the right triangle ACM. in the right triangle ACM, sinus alpha will be equal to the ratio between the angle that is in front of angle alpha, that is to say CM, over the hypotenuse of triangle ACM. And the hypotenuse of triangle ACM is actually AC, because actually CM is perpendicular, side CM of triangle ACM, CM is perpendicular to AP. So the angle CMP is 90 degrees, so CM and AP are the perpendiculars of the right triangle ACM, and AC is the hypotenuse of triangle ACM. Okay, so sinus alpha in triangle, the right triangle ACM equals to CM, the side that is in front of angle alpha, over AC, that is the hypotenuse of the right triangle ACM. So in total we got that sinus alpha equals to OP over AP, that equals to CM over AC. Now we'll copy this equality and we'll call this equality equation 1. Okay? So equation 1 is OP over AP that equals to CM over AC. Again, I copied this equality to here. I called it equation number 1, OP over AP equals to CM over AC. But from the picture you see that OP equals to R, it is the radius of the circle. So I write it here, OP equals to R, the radius of the circle. AP is defined as X, so AP equals to X. We defined AP as X. And AC is given to us, side AC of triangle ABC is given to us, and AC actually equals to 70 units. So AC equals to 70 units. So actually we can substitute OP by R because OP equals to R. We can substitute AP by X because AP equals to X, and we can substitute AC by 70 because AC equals to 70 units. Okay, so we'll do it now. So in equation 1, instead of OP, we'll write R because OP equals to R. Instead of AP, we'll write X because AP equals to X. Equals to CM, we will leave CM as it is, over AC. AC equals to 70, so we can substitute AC by 70. Again, we substituted OP by R because OP equals to R. We substituted AP by X because AP equals to X, and we substituted AC by 70 because AC equals to 70. And here we can multiply both sides of the equation by x. It is allowable because x is a positive number, x equals to AB, so it can never be 0. For that reason, it is allowable to multiply both sides of the equation by x. So we get that so we multiply both sides of the equation by x. Here, r divided by x times x equals to r, and cm over 70 times x equals to cm times x over 70. Okay. In the next step, we will divide both sides of the equation by cm. Again, it is allowable to divide the equation by cm because cm is the perpendicular to side AB of the triangle, so it is a positive number and it can never be 0, so it is allowable to multiply, to divide both sides of the equation by cm. We will divide both sides of the equation by cm. We will get that r over cm equals to x over 70 I repeat again, we divided both sides of this equation by cm. R divided by cm equals to r over cm, and cm over 70 times x divided by x equals cm times x over 70 divided by cm, so cm divided by cm equals to 1. So cm is cancelled, and we left with x over 70. So actually this is our first equation. In the next step, we'll focus on beta and sinus beta, and we will also focus on two other right triangles. The first right triangle that we will focus on is the right triangle EPB, and also we will focus on the right triangle CMB. Okay, we'll focus on the right triangle EPB and the right triangle CMB. So in those triangles, sinus beta first of all we'll focus on the right triangle EPB, this triangle. In this triangle, sinus beta equals to the ratio between the side that is in front of angle beta, that is to say PE, over the hypotenuse of this right triangle, and the hypotenuse of this right triangle is PB, side PB, because as you can see from the picture, side PE of triangle PEB is perpendicular to side EB of this triangle. So PE and EB are the perpendiculars of the right triangle PEB, and the hypotenuse of triangle PEB is side PB. Okay? So sinus beta in triangle PEB equals to PE over PB, and if we focus on the right triangle CMB, in this right triangle, sinus beta will be equal to the side that is in front of angle beta, that is to say side CM of right triangle CMB, so it is CM over the hypotenuse of triangle CMB, and the hypotenuse of triangle CMB is CB. Again, because actually in the right triangle CMB, side CM is perpendicular to side MB. So CM and MB both are the sides that the perpendiculars of the right triangle CMB, and the hypotenuse of the right triangle CMB is actually CB. So sinus beta in triangle CMB equals to CM over CB. Okay, so in total we got that sinus beta equals to PE over PB, that equals to CM over CB. Now we will copy again this equality, and we will call to this equality equation number 2. Okay, so the second equation will be PE over PB that equals to CM over CB. Okay, so I copied this equality to here and called it equation number 2. PE over PB equals to CM over CB. Now we see from the picture that PE equals to R, the radius of this circle. I write it here. PE equals to the radius of this circle, that is R. PB is AB minus AP, that is to say 90 minus X. So PB equals to 90 minus X. And CB is given to us. CB equals to 50 units. Okay, CB equals to 50. So in the second equation we know that PE equals to R, so we can substitute PE by R. PB equals to 90 minus 6, so we can substitute PB by 90 minus 6, and CM equals CB equals to 50 units, so we can substitute CB by 50. Okay, we'll do it now. So instead of PE, we will write R because PE equals to R. Instead of PB, we will write 90 minus 6 because PB equals to 90 minus 6. And we will leave CM as it is over CB. CB equals to 50 units, so we can substitute CB by 50. Okay, again, we substituted PE by R, PB by 90 minus 6. We left CM as it is, and we substituted CB by 50. Okay, so here we can divide first of all, okay, we can divide both sides of the equation by CM because CM is perpendicular to AB, so it can never be 0, so it is allowable to divide both sides of the equation by CM. We will get that the second equation R over CM times 90 minus X equals to 1 over 50. So we divided both sides of this equation by CM. We got that R over 90 minus 6 divided by CM equals to CM over 50 divided by CM. CM divided by CM is 1. Okay, CM is cancelled. So CM divided by CM is 1 over 50. Yes. Now we will multiply both sides of the equation by 90 minus 6. Actually, 90 minus 6 is PB. It is a positive number, it can never be 0. So it is allowable to multiply both sides of the equation by 90 minus 6. Because X is less than 90 units, X is AP, and the 90 units is AB, that is bigger than X, so 90 minus 6 is a positive number, it can never be 0, so it is allowable to multiply both sides of this equation by 90 minus 6. So we'll get that R over CM equals to 90 minus X over 50. So we multiply both sides of the equation by 90 minus 6. So here we have actually R over CM divided by 90 minus 6 times 90 minus 6. So 90 minus 6 divided by 90 minus 6 equals to 1. So 90 minus 6 is cancelled here, and we left only with R over CM. Okay, because we have 90 minus X divided by 90 minus 6, so it is equals to 1, and 90 minus 6 is cancelled from this expression, and we left with only R over CM equals to 1 over 50 times 90 minus 6 equals to 90 minus 6 over 50. Okay, so we have our second expression for R over Cm from the second equation, and from the first equation we have already know that R over Cm equals to x over 70, so we will copy it here. From the first equation we know that R over Cm equals to x over 70. Okay, so we have two expressions for R over Cm. R over Cm from the second expression, from the second equation equals to 90 minus x over 50. And R over Cm from the first equation equals to x over 70. So we can create the third equation that states that R over Cm equals to R over Cm. Okay, the third equation is that R over Cm equals to R over Cm. Now we will substitute the expression R over Cm by the value of R over Cm from the second expression. That is to say, we will substitute R over Cm by 90 minus 6 over 50. And then we'll substitute R over Cm in this side of the equation by the value of R over Cm from the first equation. That is to say, we will substitute R over Cm by x over 70. Okay? So instead of R over Cm this side of the equation, we will write the value of R over Cm from the second equation, and the value of R over Cm from the second equation is 90 minus 6 over 50. This equals to R over Cm, and we will substitute the value of R over Cm in this side of the equation by the value of R over Cm in the first equation, and the value of R over Cm in the first equation equals to x over 70. Okay, so I repeat again, we substituted and the expression R over Cm by the value of R over Cm in the second equation, that is to say 90 minus 6 over 50, and we substituted the expression R over Cm by the value of R over Cm in the first equation, that is to say x over 70. Okay, so now we'll multiply both sides of the equation by 50. So we multiply both sides of the equation by 50. 90 minus x times 50 divided by 50 equals to 90 minus 6. 50 is cancelled because 50 over 50 equals to 1. So 50 is cancelled. So here 90 minus 6 divided by 50 times 50 equals to 90 minus 6 because 50 is cancelled, and x over 70 times 50 equals to 50x over 70. Okay, so we have the equality that 90 minus 6 equals to 50x over 70. Here we will multiply both sides of the equation by 70. We'll get that so we multiply both sides of this equation by 70. 70 times 90 minus 6 equals to 70 times 90 minus 6, and 50x over 70 times 70, or 70 divided by 70 equals to 1. So 70 is cancelled from this expression and we left only with 50x. Okay, because it is 70 over 70 equals to 1. So we left only with 50x. Here we divide both sides of the equation by 10. So here we divided both sides of the equation by 10. So 70 divided by 10 equals to 7. So it is 7 times 90 minus 6. And 50x divided by 10 equals to 5x. Now we will open the brackets in this side of the equation. We get that so we open the brackets in this side of the equation. 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x, all equals to 5x. Here we will add 7x to both sides of the equation. So we added to both sides of the equation 7x. 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Here we will divide both sides of the equation by 6. So we divided both sides of the equation by 6. 630 divided by 6 equals to 105, and 12x divided by 6 equals to 2x. So we have the third equation that states that 2x equals to 105, but we also know that AP equals 2x according to our definition. We defined AP as x. So we write here the fourth equation that states that AP equals to x according to our definition. So if AP equals to x, then 2 times AP will be equal to 2 times 6. Yes, very simple. So the fourth equation states that 2 times AP equals to 2x, and the third equation states that 2 times 6 equals to 105. So here we will create the fifth equation that combines the third equation and the fourth equation together, and actually we will get that the fifth equation that 2 times 6 equals, from the third equation, 2 times 6 equals to 105 units, and for the fourth equation 2 times 6 equals to 2 times AP. Okay, from the third equation 2 times 6 equals to 105, and from the fourth equation 2 times 6 equals to 2 times AP. So we can add here that 2 times 6 equals to 2 times AP. Okay, and we have the equality that 2 times AP equals to 105 units. And that is actually our final answer. That the value of 2 times AP equals to 105 units. Okay, actually the question was to find the value of 2 times AP, and our answer is that the value of 2 times AP equals to 105 units, or the size of 2 times AP equals to 105 units. Okay, so now I will summarize the lecture. So we actually wanted to find the value of 2 times AP, and we have triangle ABC. The size of AB is 90 units. It is given to us. The size of AC is 70 units, and the size of CB equals to 50 units. And we also have a circle. The center of this circle is point P, and point P is situated on side AB of the triangle, and actually this circle has 2 tangents. AC is tangent to this circle at point O, and CB is tangent to this circle at point E, or the touching point of side AC if the triangle is point O, and the touching point of side CB of the triangle is the touching point of side CB of the triangle with the circle is point E, and the touching point of side AC of the triangle with the circle is point O. Again, AC is tangent to the circle at point O, and CB is tangent to the circle at point E. And PE and PE and PO are the radiuses of the circle. So we have a rule that states that in any circle a radius and the tangent to that radius are perpendicular to each other. So this angle is 90 degrees and this angle also is 90 degrees. So we can implement this rule in our circle because we have radius PO of the circle and we have a tangent to this radius. So according to our rule, the radius and the tangent to that radius are perpendicular to each other. So angle POA equals to 90 degrees and also angle POC equals to 90 degrees. Or PO, the radius of the circle, is perpendicular to AC. That is the tangent to this circle. And in the same way we can say that we have radius PE and we have a tangent to this radius that is CB, side CB of the triangle, and according to our rule the radius and the tangent to that radius are perpendicular to each other. So actually the angle PEC equals to 90 degrees and also angle PEB equals to 90 degrees because PE is perpendicular to CB. So therefore this angle is 90 degrees and this angle is also 90 degrees. Okay, so the next step we actually draw from point C perpendicular to side AB of the triangle, and we call the touching point between the perpendicular to side AB of the triangle M, capital M. So the line CM is perpendicular to side AB of the triangle. That is to say, angle CMA is 90 degrees and also angle CMB equals to 90 degrees. Okay, so actually we have we created here 4 right triangles. Triangle AOP is a right triangle because this angle is 90 degrees. Triangle the ACM is right triangle because angle CMA is 90 degrees. Triangle CMB is 90 degrees because triangle CMB is a right triangle because angle CMB is 90 degrees, and triangle BPE is 90 degrees. Triangle BPE is a right triangle because angle BEP is 90 degrees. So we have here 4 right triangles, and we defined angle CAB as alpha and angle CBA as beta, and then we actually focused on first before that we defined AP as X, so PP will be equal to AB minus AP, that is to say 90 minus X, so PB equals to 90 minus X and AP equals to X. Then we focused on triangle AOP and right triangle ACM. In the right triangle AOP, sinus alpha equals to OP over AP, and in the right triangle ACM, sinus alpha equals to CM over AC. So in total, we have the equality that states that sinus alpha equals to OP over AP, that equals to CM over AC. Then we copied this equality and called it equation 1, OP over AP equals to CM over AC. And we arrived to the equality that R over C. For that we know that OP equals to R, AP equals to X, and AC equals to 70 units. We put this data in equation 1 and we got, okay, here in equation 1, we got that R over X equals to CM over 70, and we got the equality, the equation 1, that R over CM equals to X over 70. Then we moved to angle beta, and we focus on the right triangle PEB and the right triangle CMB. And sinus beta in triangle PEB equals to PE over PB, and sinus beta in triangle CMB equals to CM over CB. So in total we have that sinus beta equals to PE over PB, that equals to CM over CB. We copied this equality and called it equation number 2, PE over PB equals to CM over CB. But we know that PE is R, equals to R, PB equals to 90 minus X, and CB is given to us, and it is 50 units. So we can put this data in equation 2. We will get that R over 90 minus X equals to CM over 50. And then we got the equation that R over CM equals to 90 minus X over 50. But we know from equation 1 that R over CM equals to X over 70. So we have in the second equation R over CM, and we have in the first equation R over CM. So we can create the first equation that R over CM equals to R over CM, and then we substituted R over CM in this side of the equation by the value of R over CM in the second equation, that is to say 90 minus X over 50, and we substituted the value of R over CM by the value of R over Cm in the first equation, that is to say X over 70. So we got that 90 minus X over 50, the value of R over Cm for the second equation equals to X over 70, the value of R over Cm over from the first equation. Okay, so it is a very simple equation of only one variable, that is X, with one equation. So at the end we got that 2 times X equals to 105 units from one side, but we defined AP as X. According to our definition, AP equals to X. So we created the fourth equation that states that AP equals to X. So if AP equals to X, then 2 times AP equals to 2 times X. So we created then the fifth equation, that 2 times X from one side, from the third equation, that 2 times X equals to 105. But from the fourth equation, that we know that 2 times X equals to 2 times AP. So we can add here that 2 times X also equals to 2 times AP. And at the end we got the equality that 2 times AP equals to 105 units. So the answer to our question is that 2 times AP equals to 105 units. Okay? Or the value of 2 times AP equals to 105 units, or the size of 2 times AP equals to 105 units. Okay? Thank you very much.